Hi, welcome to this NPTEL MOOC course on basic construction materials. I am Radhakrishna Pillai. I will be constructing this course with Professor Manu Santhanam. He has given one lecture before. Now, this is the second lecture, and before I get into the course material, let me also give a brief introduction on our research group at IIT Madras. We call it BTCM, that stands for Building Technology and Construction Management, and we specialize in the areas of building science, construction management and construction materials. So, construction materials is the focus here today in this course, and then we have 5 faculty members working in those areas. Mainly we work on cement, concrete and steel reinforcement and other type of reinforcement also. So, different type of construction materials that are used today, we work on those areas. And for more details on our division, you can look at or visit www.civil.iitm.ac.in. Okay. So, again before I go into the course material, I would like to thank the people who really made my career, and this is Professor David Trejo. I did my master's and PhD with him under his guidance, and then after joining IIT Madras, Professor Ravindra Gettu and Manu Santhanam played a significant role in shaping or in mentoring me, etc. And also all my other teachers during my undergraduate studies and in schooling, I would like to thank all of them. And my students who a lot of students from BTCM division who helped us in building one of the best laboratory on construction materials in India at BTCM IIT Madras. Thanks to all. Now, let us get into the course material. So, what is the objective of this course? Main objectives are two: to provide the scientific basis for the understanding of the behavior of construction materials, and also to provide you guidance on how to choose a suitable construction material for various applications. Okay. Now, different study materials I have used for developing this course. These are different books which we used, and also a lot of information you will see in this course which are from the internet, various sources in the internet. So, it is not just following just one book, and so a lot of information has been put together in this course material. So, for today's outline, we will look at first the history of construction materials and why do we actually study construction materials and their behavior, and what are the 3 different levels of information about various materials. And then we will also talk about durability, life cycle behavior, life cycle cost, etc. of construction materials. So, this is for today's lecture. Now, construction material, the science and engineering of it, and it involves the use of basic science in the understanding of how a material will behave. That means, we will even go into the chemical bond, molecular structure, microstructure, etc. of the material. So, that is like we will look at chemical structure, and then also how a material behaves when you talk about its stress and strain behavior. That is also very important to understand. And then once we know the stress strain behavior, or let us say thermal expansion or thermal conductivity, how the material behaves when it is applied either a mechanical load or an environmental load. So, that is something very, very important. And when a material is experiencing a mechanical or an environmental load, and its behavior could be very different depending on the type of applications or depending on the place where the material is used, etc. Now, how do we engineer a material so that it is able to withstand both the mechanical and environmental loading which is coming on to that? Now, how do we engineer? And that means engineering is a verb here, and how can we control its properties so that the material is being used in the structures. Material is able to withstand such loads while in service. And also when I say while in service, we should also think about from the cradle to the grave concept. That means when a material is unearthed or it's manufactured or processed from the soil or ground through various manufacturing procedures, and we put that into the structure, and until that structure degrades or the life is over, and we will even probably dispose the materials back into the earth. So, all that have to be considered while we choose a construction material. Now, let us go into the history of construction materials, little bit on history, which is first we used to make houses or buildings etc. using timber. Even today in some places of the world that is being practiced depending on the climatic conditions and availability of the timber. And also we use a lot of stone, used to use, even today we do that. Now, in 20th century onwards, like we have started using cement concrete, asphalt concrete, steel, polymers, composites, etc. Glass, various type of materials are in use in today's construction. Now, one question which comes is like whether all these materials are better than the one in the past. Maybe not always. Like there could be some properties which we enhance, but some other properties might not be enhanced, or it might be less also. So, we have to really see what is that property which you want, or what are the properties which you want from a particular material system, and the material in use is actually able to provide that or not. For example, in some cases strength may be very, very important. In some other cases, for maybe some other properties like thermal conductivity may be more important. So, you have to see, but without compromising the strength. So, you have to see when you talk about a material selection, all the properties have to be considered before we choose. Now, material research can solve some of the problems, or if you have an issue, it can help in developing new materials and technologies. One example which I am saying here is, let us think about clay. The old homes, the people used to use clay, but it was probably not strong enough to make multi-story buildings etc. So, we started making concrete, and then in concrete itself we started making concretes with, or the concrete with very, very high strength. For example, the few decades ago, if you think about concrete, you would probably talk about a concrete with a strength of 10 MPa or something around that. But today when we talk about concrete, we talk about easily M30, M40, even up to M100. M here is like 100 MPa plus concrete. Its M is the characteristic strength. We will talk about that later. And then in terms of the metals, if you talk about metals, earlier we used to have iron, and then people made cast iron. Then they found that cast iron is very brittle, so they made steel which is more ductile than the cast iron. So, this evolution of these various metals, it evolved, and now today you have numerous type of metals available which have various properties which can cater to various requirements of the industry. So, like that, materials research is very, very important when you talk about even in civil engineering construction. Okay. Now, why do we need to know about the science and technology of material? Because the behavior of material systems depends on the properties at both macro and micro level. So, microstructure is very, very important, and also the macro behavior, how the material systems are put together, that is also very, very important when we talk about a behavior of a building, for example, or a bridge, for example. Now, various information at different levels have to be brought together to give the foundation for materials technology which is needed for practice. Practice, when I say a material like which is used, let us say bridge, you use steel and concrete to make the bridge. If the bridge has to perform in a good way for long period of time, the properties of the steel has to be good, the properties of the concrete have to be good, and also the when they put together steel and concrete as a composite system, that the system also have to perform very well and meet all the requirements. Now, for this to achieve, the material testing, how the material is processed, how it is handled and placed in the structure, and also the basic science behind all this have to be very thoroughly understood. Now, hence, because of all this, training in the science and fundamentals must be preceding the development of new and better materials. You cannot really make a new material without really understanding the science and fundamentals behind, science behind it. So, science is very, very important for application, which is essentially the engineering. Okay. Now, what are the three levels of information we talk about? When you talk about materials, especially in construction, I am going to talk like three levels. One is the information which is available at molecular level, and that we can say even nano or micro level information. And then the next one is materials structure level information, not the engineering structure, but the material structure level information, which we can say mesoscale, and then engineering level information, which is slightly larger, which we are going to call it macro scale. So, you can see the pictures on the right side, the molecular level, and then when you talk about stress strain behavior of a particular material, that is the material structure level information, an example. And then also if you are talking about a beam, or how a beam will be made out of steel concrete system, how it is behaving, that is all about engineering level. Now, I will talk one slide each on these three levels of information. In molecular level, you can see the sketches and images over there. We are talking about atomic bonds, we are talking about lattice structure, crystal structure of metals. So, on the right side you can see an example which I am showing for clay, where you can see different layers. Clay materials typically are layer type materials, and then how it's when you look through a microscope, how it will look like, that is what is shown on the bottom right. So, other examples of this atomic level or molecular level information are the type of chemical complexes which are present. For example, in concrete you have calcium silicate hydrate, which is the binding agent in cement concrete system. And when you talk about wood, you have cellulose molecules, which are essentially a key player in the which influences the properties of wood, and polymers, composites, etc. Now, the physical structure and chemical composition can explain material properties and the evolution of materials over a period of time. One example is, let us say you are talking about concrete, and when concrete becomes hardened, or it continues to react, and from the day one, after some days it will evolve, the properties will evolve, the strength will increase, the pore structure will get more refined. So, a lot of chemical reactions happen when we mix cement and water together. Okay. Now, how these strength, pore structure, etc. is changing over a period of time can be a very good information to determine whether that particular concrete can be used for a particular application or not. Especially if you want to talk about a structure which will last for 100 years of life, we need to know that the quality of the material will be so good at microstructure level, and based on that we can say whether that structure will last for 100 years or not. So, a lot of science goes behind this. Now, when we talk about material structure level, that is the second level of information I mentioned, and it can be considered as a composite of different phases which interact to give the total behavior. So, picture on the right side you can see a clay brick. Okay. So, how the clay materials are when they burn the clay, like you heat it up. So, there are a lot of chemical reactions which happen, and the final product, or the hardened brick, that will you can look at how the microstructure of that is, how the different sand particles or clay particles, they interact, they bind together, all that we can look at. And of course, if clay made in one place may not be same as in another place, or if you don't heat it properly, you will not get the properties which you are desiring. So there are a lot of chemical reactions are involved in the making of clay, and if we know the type of clay materials which are used and the type of processing like the heating treatment etc. which are being used, which each clay each the entire clay brick, how they experience and how the reaction between various phases or various material elements within the clay system, how they react, how they behave, how well they are bonded together, all that can tell us what could be the strength of the clay, the brick, and how that brick will behave, whether it will behave in a very brittle manner or how much strength it will have, etc. And the third picture on the right side, as the bottom right corner, you can see the interface. You also talk about, when you talk about a clay brick wall, you also have to worry about how the mortar in between each brick, they are bonding or binding the clay bricks together as a single wall unit. So all these interfaces, how the properties at the interfaces are, that's also very, very important, in addition to the interface between the various particles within the clay. Okay. Now, the phases and interfaces can often be tested, and then behavior can also be modeled. Now, the third level which we talk about engineering level is called engineering level. I am also taking an example of bricks here because that is what we have been talking. So, and probably you are more familiar with that also at this stage. Now, consideration of the total material normally taken to be homogeneous and continuous, and then size of the representative. When you talk about engineering level, you need to understand what is the size of a representative unit. Now, here the representative unit is not just one brick piece, but a small area of the of a brick wall, where the brick which is used, the mortar which is used, all play a role in the behavior of that panel which you see on the top right image. This image here, you can see that it is not just one brick which is being tested. So they make a panel of brick and then apply some load on it, and then see how that brick wall element or a representative unit of a brick wall is going to behave. Now, once you understand the properties from this representative unit, then you can actually even model on a as you see on the bottom right, there is a testing which was done on a structure itself. So, to see how the structure as a whole will behave. So, all this can be done, and this is where we are talking about engineering level, and such information is very useful in designing structures for various applications. So, the point here is we have to understand how, from the chemical structure level or a very molecular level, what type of material is used, how the different chemical and physical properties are, and also at the macro level, where we are talking about elements of size in meters, etc., where from nano to meter scale, we are talking about different levels of information. Okay. Now, let us talk about what you have to consider while selecting a construction material. So, one thing is cost effectiveness, then the desired performance for the entire life of the structure, then the essential criteria that the material must satisfy from the beginning till the end of the life of the structure, and then other application specific criteria also we have to look at. Now, cost effectiveness for the purpose for which the structure is designed. For example, you can design a bridge considering different material options. Okay. Now, the cost will depend on what type of material you are using. If it is a wooden bridge, it might be a different cost. If you are talking about a concrete bridge, or if you are talking about a steel bridge, the cost will change significantly. So, we have to think about the cost of the structure while we designing the material systems or itself, okay, or cost have to be has to be kept in mind. Then the desired performance. When we talk about desired performance, that means the material should perform adequately during the construction in service period and also during the failure and demolition phase. Okay. So, from the beginning till the end, that is from cradle to grave. So, the structure should, or the material system should perform in a desired fashion for this entire life of the structure. Now, during this time, what are those essential criteria that the material must satisfy? We know that mechanical criteria, for example, strength, it must satisfy the strength requirement, otherwise the structure will collapse. And also it must satisfy the deformation requirements, otherwise there may be too much deflections. For example, if you are riding on a bridge, a car on a bridge, if there is a lot of deflection, you won't feel comfortable for sitting in that car. So, you may not want to even go on that bridge. So, deflection limit is very, very important to consider, or that is coming from the deformation of the material. It is not the failure or breaking the material into two pieces, that is something to do with the strength criteria. When you talk about deformation, it is more of a elastic behavior of the material, and also you have to think about the durability of the material system. How long these strength and deformation criteria will be met? Will it be same as in year 1 and in 50th year or even 100th year? So, whatever is the design life requirement for that entire life period, you should have strength and deformation criteria. If it is met, so then we can say the system is durable in nature. Okay. Now, also there are cases where other application specific criteria have to be met. For example, if you are talking about a water tank, water tightness is very, very important. In addition to the other three criteria, strength, deformation, durability, also in addition to that, the water tightness is also very, very important to consider. Then also the material which we use should be environment friendly. You cannot use a material which will cause or which will lead to a lot of carbon emissions or energy consumption. So, all this also have to be think about. So, nowadays there is a trend for using recycled materials or material which is already mined from the earth, already used. We try to reuse, recycle the materials so that it does not lead to significant amount of the carbon footprint of that process is going to be less. And also you have to think about aesthetics, how beautiful the structure looks like. If you are talking about a house, you want your house to be looking very good, not like a simple boxes put together. And also the speed of construction. In construction, speed is very well associated or correlated with the money. So, or cost of construction. So, if something takes 6 months to construct and if option B is going to take 1 year to construct, so definitely we might go for the one which takes only 6 months to construct without compromising the quality. So, you cannot pick an option where you can finish the work very fast, but if you are compromising the quality, then it is not a good option. So, without compromising the quality, you should be able to provide or you should be able to complete the construction in as fast as possible. Now, when you talk about money, economic factors, what are the factors which affect the cost of construction? Definitely availability of the raw materials is very, very important. If you are talking about civil engineering construction, usually whatever material we talk about, we consume them in very large quantity. So, when we consume them in large quantity, you have to think about the unit cost of the unit material and where you can get it from, and how what is the impact of having that the type of material, the availability of the material, the transportation cost of that material, all these have to be thought about, and so that you can look at which is the most less expensive option or an optimal option, again without compromising the quality of the construction. Now, how can we reduce manufacturing costs? If we can design the systems by having repetitive type of elements or similar type of element, more in number. For example, brick, if you think about brick, if I'm making every brick at site, it is going to be very costly. But if I make the brick, it's already manufactured product, you can just order large in number, and so the cost of individual brick comes down significantly. And another example for that is precast elements. For example, if you talk about concrete structures, nowadays there is a lot of trend towards the adoption of precast technology. That means the elements are made in some other place in a factory environment where the quality is also controlled very well, and brought to the construction site and assembled at the construction site. So that technology is picking up very fast nowadays, and it's a need for need of the hour, because we need to there is a huge requirement of significant amount of construction in our country. So precast construction technology is very much essential, I would say. And also sometimes precast may not be possible because you cannot really transport these materials or the precast elements to the particular site. So in such cases, you might have to go with cast in situ option. Placement means the placing of concrete or whatever the material which we use. So you have to see if precast is an option. If it is not, maybe you will have to go with cast in situ. Especially if you can think about a design where multiple number of the same type of elements, if we can design the structure in such a fashion, like example a bridge structure, there are a lot of beams which are used in bridges, and all those beams might be can be designed in a similar fashion, and we can, in that case, we can actually have these beams made somewhere else, brought to the site, and then just only you have to do is assembly of that to make the bridge. So that will reduce the cost because it reduces the activities at site, at the construction site. Time taken will be less, so effectively your cost of construction can significantly come down without really influencing the, or without really affecting the quality in an adverse manner. Now also we have to think about maintenance. If a particular material which you have selected requires frequent maintenance, then in the life cycle of the structure, the cost might be actually more. So when you do cost comparison across materials, what you have to look at is not only the capital, but also the life cycle cost. So life cycle cost is something very, very important to think about. This have to be brought into many construction projects. So how the choice of materials affect the life cycle cost of the structure, rather than only looking at the construction cost. Okay. Now when you talk about life cycle cost, I am going to show you an example which will help you understand what I am talking. Now here you have two options. One is conventional material alternative and a durable material alternative. Now you think about an example of a shoe, pair of shoes. You can see in the first one, this person has to repair the shoe very often. In the second option, I am going to say that this shoe is a very good quality shoe and you do not have to repair that very often. Okay. Now look at the top half of the graph where you have a $CC, okay, or you can say construction cost with respect to a conventional material. The subscript is for conventional material, and this one and the bottom one, this is for durable material. The subscript D is for durable. Now in case of conventional material, there are 1, 2, 3, 4, 5, 6 times repair has to be taken, has to be done. Or for example, in case of a shoe, if the shoe is not of good quality, okay, and you are roughly handling the shoes, even same thing in the structures also, there could be cases where the structures experience severe exposure conditions, etc. So it can start corroding, etc. So in case of shoes, you can think of an example where poor quality shoe, or a shoe which is not able to withstand the loads which is coming while we walk. So you have to replace this. So at the time of replacement, you have to actually go to the shop, cobbler, you have to go meet the cobbler, and then you have to get the shoe repaired. Now, when you do that process, you have to take a day off to go to the shop, to get that job done, to fix the shoe and then start using it again. So, there is a and on that day you cannot use that shoe, and also you cannot do other work because you have to spend some time on repairing this. Similar thing can happen in a structure also. When a structure undergoes repair, you cannot use that structure on that day or during that repair period. Let us imagine a bridge. If there is a work going on, you cannot use that, you have to close the bridge. So, that will affect a lot of other things. Like in the case of a shoe, when you go to the shop, you cannot go and do other routine things. So, there are a lot of direct and indirect cost coming into the picture. Here we are talking only direct cost. That means, so you have to do the repair, so there is a repair cost associated with it. So, that will be there for, let us say, every 3 months you have to repair the shoe. Okay. In the second option, if you go for this good quality shoe, maybe you will have to pay a little bit more money. Let us say you pay X amount of money extra. Okay. But if you do not have any repair, the first repair is coming here. I mean, no, not even repair there, because that is end of life. So, you have very long service, uninterrupted service. In the first case, you have to keep on repairing. So, there is a lot of interruption of the service of the shoes. In the second case, the shoe, you are able to use the shoe for long period of time without any problem. Which one you will prefer? I would say we should prefer the durable option or the good quality shoe, so that you can continuously use that shoe for long period of time. Same case for structures also. If we are able to afford the a little bit of extra payment in the beginning, okay, then if you can avoid all the intermediate repairs and get like the time to first repair, if you can increase the time to first repair, if you can increase, that is always a better option. And this will definitely reduce the life cycle cost, because in the first case, the life cycle cost is the cost of construction plus all these repair cost. That is what is life cycle cost. In the second case, the life cycle cost is only this, that is it. There is no repair for the desired service life. So, when you look at these two options, you might find that going for a durable option, maybe it is a little more expensive in the beginning, but your life cycle cost is going to be significantly less as compared to a poor quality material in use. Okay. Now, again, some more things to consider while we select. I already discussed this, but I will just show this with this schematic, so it is very easy for you to understand. When we talk about any material, we first take it from the earth. Okay, let us say aggregate or cement, anything which we talk about construction, it is all coming from the earth. So, you take there will be a mine, you take the material, and then you manufacture the particular product. Okay. In case of, let us say, concrete, you make the concrete, you may have to make cement using limestone, clay, etc. You make cement, and then using aggregate, cement, etc. you make concrete, and after that you use that material at the site, and during that time what happens, or you use it, and then during the occupancy of the material, that is exposed to the external environment and also the structural loading. So, both mechanical and environmental loading are important, okay, during the occupancy. So, because of mechanical loading, the structure might start cracking, etc., and during the environmental loading, it might have some chemical actions on the structure, which might lead to some deterioration, which might eventually weaken the material. So, it will also occur cracking, etc., or deteriorate. So, during the occupancy, you have to maintain the structure very well. If you do not maintain, it is not going to have long life. So, maintenance is also very, very important, but during that time, the material can degrade during the service. So, eventually, you might reach a stage where you have to demolish the structure, okay, and demolish and build a new one. Okay. So, at that process, during that time, we can also think about, can I recycle, reuse, or I have to dispose the material. If I can recycle or reuse some of the materials, it is very good, sustainable option. If I have to disposal, okay, so you dispose back into the earth and then done with it. So, this is the life cycle of building products or building materials. Various materials which we use, we end up in either recycle, reuse, or we have to dispose the material. Okay. So, choice of materials and how do you demolish, all that should be thought through so that we can maximize the reuse and recycling of material. That is today's requirement. Okay. So, to summarize, we look at the history of construction materials, why to study construction materials, and we also looked at different levels of information about material, that is from microscopic level, and then we looked at the materials science materials level, structure level, and then the third one was on the engineering structure level. Then we also talked about life cycle behavior, cost, durability, the whole life cycle, how a material what are the various things to be considered while selecting a material. It is not only to select a material, we should not select a material based on only the initial performance, but we have to think about the life cycle performance. So, if you are designing a structure for 100 years, you should choose a material which will actually last for 100 years without much of maintenance or minimal maintenance cost. That way we can reduce the life cycle cost of the structure. I think with that we will stop today's lecture. I would be for the course material. So, this is something very important, and I thought I will put this in first day itself, which is on importance of learning how to write technical reports, okay, or ability to technically for technical communication, and also how to do how to make good drawings, engineering drawings. Okay. So, look at this photograph of or a sketch of a cup, coffee cup, how a cup, you can make a 2D drawings on this. And then why I am emphasizing this here is it's very important to communicate our thoughts and ideas to other people. Drawing. So, we have to develop skills for preparing good engineering drawings to transfer the technical ideas to other people. Okay. And also through writing we should be able to communicate. So, both these are very important means for communication, technical communication through writing and through drawings. So, please focus on these two aspects, which are very important when we think about long life, successful career. These are very important. So, please put some effort on that, and this is a book which I found to be very good book for this learning how to write technical reports. Thank you.